So today we will do JUnit testing. JUnit testing. The topic is how you do unit testing in Java. So what we are going to talk about today is unit testing in Java. So first thing to understand is what is unit testing. Okay, unit testing is basically testing or your lowest level class objects. So you want to test all the public interface methods or public class methods that you have written. So unit testing is used to test all your Java classes, and you test the public methods of your class, or sometimes you test the public methods of an interface which are implemented by some class. So in unit testing, you're basically testing the smallest code units, which are nothing but your classes. Do you write tests to test private methods? No. You only write tests which test the public or sometimes the protected methods. So your unit tests are used to test the public methods of a class. And the most popular framework that is available to do unit testing in Java is called as JUnit, and it is written as the J uppercase, U uppercase, N lowercase, I and E. So J in JUnit stands for Java unit testing. In the .NET world, in fact, it's called as NUnit. In the .NET world, I'm just giving you an analogy. Okay. In Windows, for everything, all the frameworks, they generally start with the letter N. Like for example, we have Spring in Java, and then you have the corresponding framework in .NET called NSpring. I'm just giving you as a reference. So whenever you see something which starts with an N, you know that it is meant for Windows. For example, in Java you have Hibernate. In Spring, in the Windows world, you have NHibernate. Okay, so let's see how you write a JUnit test case. So what we do in JUnit is Let's say you have a class called, I'm just taking an example of a class. Let's call this class as arithmetic operation. And let's say this class has the methods add, and let's say it works only for integers. So let's say it takes two integer arguments. Multiply and so on. It will multiply two integers, or generally, let's, for simplification, we'll just take two integers. Two integer arguments. Okay. Now, I also want to introduce a concept in which is becoming very popular nowadays. Actually, it's been there for a couple of years now. It's called as TDD. TDD. It stands for Test Driven Development. So in test driven development, what you do is you think of the class first and all its public operations. Okay, let's say these are the public operations of this class. So in test driven development, you don't go and implement those methods first. Okay, you'll just provide what are called as stubs. You say, can you stub out the implementation? That means you're just providing an implementation which just satisfies the signature. So if the return value of add is an int, you just return a 0 or something, just to indicate, just to make it compile. It will not do the logic it is supposed to do, but you just stub it out just to make it compile. So the stub just ensures that the methods will all compile. But with the stub, the runtime implementation runtime values may not be correct, right? So what you do is you first create stubs for all your public methods, return some dummy values. It will fail at runtime if you try to, it won't fail at runtime, but it will give you incorrect values. Let's say if you add 3 and 4, and in your method you always return 0. 3 plus 4 should be 7, right? It's not 0, right? So that's a stub. It just ensures that your method will compile, because the return value of add is int and you're returning 0. So what you do in test driven development is, first you write test cases. So always write first write test cases first. Since you only have stubs and you know implementation, so after writing the test cases, when you run the test cases, all test cases will fail. Yes. Then you go and provide the implementation for your public methods and run the test cases again. Now the test cases should pass. So in the step 1, you write test cases first and all the test cases will fail. Then you implement the public methods. Now if you run the test cases, all test cases should pass. And for every public method, you should create one test case. A test case is a method in which you are testing a public method. Generally, you have at least one test case for every public method. Okay? For every public method, in your class or interface, should have at least one test case. So let's try this with an example. So I have created a class here called arithmetic operation, and in that I have an add method. It takes two arguments, x and y. Ideally, if you're doing some logic here, you will say return x plus y. That would be your logic, right? But I just want to show you test driven development. Initially you don't implement any logic for your methods. So I'm returning a 0, which is basically stubbing it out. If I don't return 0, it won't compile, right? Okay? Implement, sorry. Okay, now we'll write a JUnit test case for this. So what you do is, I have created a package here called com.training.junit, and in that I'm going to create you go to say new, and then here there should be a JUnit test case. And then here I can choose the class under test. So click browse, and then we'll type arithmetic operation. The type name is empty. So let's call it as this is the name of the class. And then which method stubs would you like to create? Let's take setup and tear down. Yeah, I'll explain it in a moment. Next. Then he's asking you which methods you for which you want the test method stubs to be created. So I'll just choose add. Okay. So we are going to test the add method, right? And create create task for let's choose these also. Say finish. So we have the arithmetic operation here and we have the arithmetic operation test here. For this example, I'm putting them both in the same directory. Normally what you do is you put your source files in one directory and your test classes in another directory. Okay. The package, yes. No, the package may be the same, but the folder which contains that package may be different. So you can have like source, under source you will have com training JUnit. You can also have a source dash test under which will also contain com.training.junit. If two classes have the same package, they still don't have to be in the same directory, right? Because all it matters is the whether the package name matches the directory structure. I can have com training package, this arithmetic operation test.java under src-test directory. Similarly, I can have com training JUnit arithmetic operation.java under src directory. So at the very top, I can have one directory for source and another directory for source test. In fact, let's do that. Okay, I'll create a new folder and I'll call it as, let's say, test. So it'll have all the test code. Okay, or you can call it as src test if you want. Just call it test. The training. So see, it is under here itself. And then what I'll do here is this guy arithmetic operation test.java. I will just move it. How do you move it? Refactor, move. So I moved it into test. Oh, but here the package name is not right? How come it's not complaining about the package name? Oh, because one second. Let me look at the properties of this project. Where are the properties of the project? Configure build path, go to source, and then we'll add one more folder called test because it's thinking that this is not a source folder. Say OK. And now see, the test was not under the source folder. That's why the test folder was only the src was part of the sources. So what I did was I went to build path and configure build path, and then you go to the source tab and then choose add folder called training test. By doing that, you're telling Eclipse that you have some source files under training test folder as well. Otherwise it will take only the files from training source. Because when we first created the project, we said all our source code is in the src folder. Okay. Now we get the error. Now we'll fix the error. We'll click on it and say move arithmetic operation to package this. So let's see what it does. See, now it creates that package. Do you see that? Yes. Let me just clean this project. Seem to be some errors. So now what we are doing in this test is, see, it created a method called test add, and it also created a stub which will fail the test. So let's run this test. The way you run that test is you say run as, and then you say JUnit test. See, it automatically detected that it's not an application. So let's run this test and see what happens. And it failed because we have a failed. You're saying it's not yet implemented. Now we have to go and implement it. It says assertion error not yet implemented. Okay. Which one? This red sign means it ran and it failed. So first we have to do is, what we have to do is implement this test, right? So what we do here is, so what I can do here is, I can create an object of arithmetic operation. I just created a short form for it. It's an object of arithmetic operation, right? You invoke the constructor to create an object of the class, right? And then I'll say aoper dot, it's a method called add, right? Add, say 3, 4, right? And it will return something, right? And then I'll say, I think there is a assert, there's a method called assert, and you can say assert equals, yes. So what I'll do here is I'll type assert equals, so I'll just type it in, okay, and I'll say 7 int comma actual value then what I want to do is I want to say whether I'll just define something called as expected value called as 7, right? Then I'll use assert equals 7 comma actual value, oh, you have to give the message first. So here we'll say actually we won't give any message first, okay? We'll say expected, we won't give any message, we'll just use it as it is. and then we'll remove. Now we have implemented the test, right? So what we are doing in this, so we can remove this line because now we have. So what we are doing is we are creating an object of a operation, arithmetic operation. We are calling the add method, and whatever it is returning, we are storing it in the variable called actual value, and then we are declaring a variable called expected value as 7, and then we are asserting, like the word in English also, the assert means to make a statement, right? You are saying that when assert equals means you are asserting that this and this are the same, right? Since you have not provided the implementation, you are returning 0 right now, right? From that add, this test will still fail. So this is what is called as test driven development. So you first write the interfaces, and then you write the test cases, and all the test cases will fail because you haven't provided the implementation. So it builds a good habit in the software developer to always write the test cases first, and your software is going to, once you implement the software, it's going to pass all the test cases. So you have like a working module, a working unit of work. So your class becomes a fully tested class. Okay, so let's run this again. Save this and say run as JUnit test. Launching, and it failed. Let's see what message is. Assertion error, expected 7 but was 0, right? That's what we did, right? The first one is expected and the second one is actual. So now our test cases are failing, right? Now we'll go and make the test case pass. And how do you do that? So you'll go here and provide the implementation for this. So what do you have to do? Instead of returning 0, you'll return x plus y. You won't return 7. Then it will fail for some other test case, right? And now you can remove this to do also. Okay. Whatever value we are passing from here, right? In our test case, we are passing 3 and 4. Okay. Now I'll run this test case again. Now it should pass because we have gone and provided the implementation. See? Green. Got it? Now I want you to do the same thing for subtract, multiply and divide. Okay? So I'm going to stop my recording. Just 1 second.